So the second term is traction limited acceleration. So ini just simple lah. You can use or apply Newton's second law. F equal to m a. Acceleration pada versi x. So x equal to maximum traction limit force over m. Okay, macam mana cari m? Mass of the vehicle. Okay, senang saja. Come from this equation. Total weight of the vehicle equal to mass of the vehicle times gravitational. So m equal to W over G. Ni you boleh solve Fx over W over G. Ini sama dengan Fx map times G over W. Okay. Okay, W tahu W. You just tambahlah WF tambah WR. Ini W equal to WF weight at the front axle plus weight at the rear axle equal to berapa ni? 5093 3950 Newton. So times 9.81 over 3 apa tadi? 3950. Dapat berapa? Okay, minta solve yang ni. Dua-dua equation ni. So dapat berapa? Dekat maximum 34. Ini dapat
42.84 42.84
yang bawah ke yang atas?
Yang bawah. Yang bawah.
Bawah 2.84.
Yang purple. Yang purple.
Lebih kurang dah. Yang atas, yang warna blue. Oh, you kira berapa?
Blue 1143. 1143.9%.
Okay. Lebih kurang lah 1143.9.
Yep.
0.9 maksudnya 144 lah. Okay dah, 9 lah. So, untuk sini 43.9. So, you dapat lebih kurang 2 point. Apa tadi?
2.84
84 meter per second square. Okay. So, for the rear solid axle with non-locking mechanism, you get the maximum tractive force is around 1144 Newton, and the tractive limited acceleration is 2.84 meter per second square. Okay. Okay, that one is for non-locking. For locking, maksudnya term yang ni tak ada. Term yang ni tak ada. For locking mechanism. Right? So, for locking mechanism, you akan dapat for locking mechanism. Okay, equal to delete yang saya pangkal ni. Okay, so cuba kira berapa Newton, and itu you pun kena cari you punya limit acceleration x equal to berapa meter per second square. Okay, cuba kira dulu. Sama tak dengan jawapan? Sama tak? Okay. So, in summary, for real solid axle with non-locking differential, maximum effective force is less than locking differential punya mechanism. And then for locking differential mechanism, the maximum the acceleration is larger than non-locking differential. In summary lah. So tentang rear drive ataupun rear axle So minta lepas ni tadi balik mungkin soalan akan keluar front pula. Front solid axle. Macam tu lah. So benda yang sama benda yang sama. Rear axle tapi saya tukar nilai. Question number 1. You are given the following information about engine and drivetrain components of vehicle as listed below. Okay, first table is the final drive punya information, and then second table regarding the engine inertia and also the engine speed or torque, and then the last table is regarding the transmission. There are two sub-questions here. A, you need to determine the effective inertia drivetrain components in the first gear and fifth gear. Okay, you need to determine the inertia. Okay, in the first gear and fifth gear. So ada dua lah, first gear and fifth gear. Okay, and then B, question 2, to determine the maximum tractive effort. Okay, first and fifth gear of the vehicle. Okay, first gear and fifth gear. Okay, so back to question 2A. Okay, what is effective inertia? So you may refer to your notes, chapter 2 notes. Inertia sebelah ni. Okay. Here, the second term here is the effective inertia. So you need to use this equation. Need to use the equation. So, okay, go back to your question. Dulu. So, meter, what is the symbol? What is the symbol of each parameter? It's not you nak masuk dalam equation. Okay, final drive inertia ID. Okay, ratio final drive and F. Efficiency folder. Wheel inertia IW. Wheel size R. Okay, engine inertia IE. Okay. And then inertia for transmission I T. Dia ratio dia N T. Efficiency ialah ibu ni lah. Okay. So you notice ini, each gear dia ada inertia, ratio and efficiency punya value masing-masing. So each gear tak sama dia punya value. Okay, and then to solve the first gear, you kena refer first gear punya value lah. If fifth gear, you kena refer so lain value untuk inertia for transmission IT, ratio pun lain, and same goes to efficiency pun lain. Okay. So go back to the equation, effective inertia. So you kena guna yang box warna purple tu to solve the effective inertia. Okay.